In this video, we're going to cover section 2.2 of limits and these 5 basic points, starting with the basic info about limits, if there's a hole in the function in a limit, and non-existent limits. Left and right hand limits. And lastly, piecewise functions.
To define a limit, it is defined as whether from both sides of an equation a point is approached. So the point 1, 1 on this graph is the limit as x approaches 1 of this function, f of x. The point that is approached from both the right and the left is equal to 1. So this function, the limit, is equal to 1.
Another situation with limits is when there's a hole in a function, otherwise known as a removable discontinuity in a function. It is typically when there's a 0 in a denominator of a function. Therefore, the point doesn't exist when the denominator is 0. An example of this is with the function x squared minus 1 over x minus 1, which the graph looks like this. And at the point 1, 2, there's a hole because the denominator is a 0. However, because from the left side of the equation and the right side of the equation, both parts of the function approach 2, the limit is 2.
Non-existent limits are defined as from the left and from the right, they approach 2 different values, and thus the limit at this point does not exist. It is written as the limit as x approaches a from the left is equal to L, and the limit as x approaches a from the right is equal to, let's say, z. The limit as x approaches a from the left does not equal the limit as x approaches a from the right, thus meaning this limit does not exist.
Once again, using the definition that a limit only exists if and only if it approaches the same real number from both sides, we can see in the equation 1 over x squared, which looks like this, the limit as x approaches 0 does not exist because as x approaches 0, it does not approach a real number. Simply, it approaches infinity instead. So the limit does not exist.
So here we are defining limits from the left and the right side. The left side is defined as the limit of our equation, x minus 3 over x, as x from the left approaches, how about 0? That is approaching from the left because from the negative coming in from the left. Our equation over here is the limit of our equation, x minus 3 over x, as x approaches from the positive to 0, coming in from the positive and going towards negative infinity. And here, both of these are definable. We have discerned from before that if 2 points for a simple limit approach a non-real number or not the same number, they do not exist. But for coming in from the right and the left, they do approach limits. This one from the left approaches positive infinity, and this one from the right approaches negative infinity.
Another type of problem we encounter with limits is a piecewise function. So we are using these two functions here to show an example. The first function is x squared when x is less than or equal to 1, which is this one right here. And the second one is 3 minus x when x is greater than or equal to 1. So the limit when x equals 1 would simply be 2, because at the value when x equals 1, the only value there is 2. However, if you were to say the limit as x approaches 1, that would not exist, because as we defined earlier in the video, from the left-hand side of the equation, it approaches 1, however from the right it approaches 2, therefore the limit does not exist. However, as we have also learned with our left and right hand type functions, as x approaches 1 from the left, it equals 1, while as x approaches 1 from the right, it equals 2, because from the right it goes to 2. So this is another type of problem we encounter with.
Here we work on the idea of guessing a limit. When sometimes limits don't come out so nice, or sometimes they are kind of nice, you can always guess the limit instead of having to take the limit, because you see that as you approach this point 0 where there is no number, it does not exist, because at 0 this function does not exist because you're dividing by 0. You approach at 1, so way over here and over here, plus or minus 1. You're at 0.84414, so you're close, you're getting there. Then you start moving closer to number 1 and y, plus or minus 0.1, 0.998, close. But just to be safe, you go to the even closer extent of plus or minus 0.001, and that's 0.999. And then from that safe assumption, you can assume that these two functions, bearing in mind that there shouldn't be anything crazy happening in here, approaches the value 1. And then from here, you can write down that the limit as x approaches 0 of our function sine x over x is equal to 1.
Okay, so to recap what we learned in this video about section 2.2, firstly we learned about the basics of limits. A limit is defined as x approaches a, for the function f of x, it approaches value L, and that is the limit. Next, we learned about a hole in a function. When there's a hole in a function in a limit problem, there's a 0 in the denominator, therefore the point does not exist there. However, we learned that even though there's a hole in a function, it can still have a value if it, from the left and right hand side of the equation, approaches the same number. Next, we learned about non-existent limits. A limit exists if and only if it approaches the same real number from both sides. If it approaches infinity, then it does not exist. We also learned about left and right hand limits. We learned about the nomenclature for it. A negative means from the left and a positive means from the right. And even though if x approaches a different value from the left and right, for a left and right hand limit only, you can have two different values if the question's asking specifically for the left or right. Also, we learned about piecewise problems, and we learned that there can be a different value when x equals L, and when x approaches L from the left, and when x approaches L from the right. Lastly, we learned about guessing, which is when through algebra you can assume the limit of a specific value of a function. So an example of this would be when sine x is over x, it is undefined, or you can't figure it out at 0. However, if you use guessing and get closer and closer to 0, you get closer and closer to the number. It does equal 0 and then can infer what the value is. For example, you would start out when x equals 1, get more accurate when x equals 0.1, then 0.01, then 0.001. As you approach closer to 0, you'll get closer to the value of what the answer is.